So earlier we did this and we calculated the part A of this problem. So for this non-homogeneous autonomous linear system, we calculated the critical points. And we found that the critical point is -3, 4. Now, they want to use a numerical solver to determine the nature of the critical point in part A. So determine the nature of this critical point. So I open calcplot right here. And the first thing that I'm going to do is I'm going to go to vector field. Then from vector field, I'm going to ask it to show systems of differential equations. And then I'm going to input these differential equations. So dx dt is equal to 2x plus 3y minus 6. So let's write that in. 2x plus 3y plus 3y minus 6. Now at the bottom, we're going to write this one right here. So that one's going to be -x minus 2y plus 5. And this is 0. So now that we have this, I can press on this button and we see all these arrows and you're like, oh my gosh, what do I do? Well, use fixed length for all vectors should fix that. And you can scale these vectors even more if you want, like 6. But it's really just because the window is kind of small. So I would say let's go to -4 and 4 and 4. And here too, -4 and 4. Okay. So now that we have this, let's put -3 and 4 in. How do we do that? Let's close this by clicking back on this. Then bring down this and click on point. We're going to get -3, -3, 4, and 0. That's the point. So what's the nature of that point? Well, maybe we need a little bit more here. So let's go over here and let's put maybe 6 and 6. Well, we really don't need the positive, right? We just need the negative. So let's keep that to 4, or we can even put that. Well, let's leave that to 4, but this one we'll put it to -6 and -6 because we're in the negative. Oh, this one actually is the positive for the y. So we'll leave this like this. Okay, so that we can see a little bit more towards it. So it looks like it's very hard to get to that point. It kind of looks like a saddle. Let's see if I can touch it. See, it's so hard to touch it. So it looks like this point is unstable. Now, they're asking us to investigate the relationship between this and this other system. So the system that doesn't have the -6 and the 5. So let's do that. Let's go over here and let's put another vector field and let's ask it to show the differential equation, to show fixed length for all vectors. And I don't want this to show yet, so I'm going to take it out. And I'm going to write 2x plus 3y, 2x plus 3y. The bottom is going to be -x, -2y. So -x, -2y. And now, of course, they're overlapping. I'm going to turn the other one off. And now I'm going to ask it for more vectors. So let's say I want 15 vectors here and 15 vectors here. Okay. So now, this is the other one. It's a mess if we put them together. Let's just keep it at 1. That's the old point, though. Now, the other point, 0, 0, it looks like it's also a saddle, right? So it looks like they're both saddles. And what is the relationship? Well, this is at -3, 4. So it looks really, I want to say, so that's negative negative 3, 4 right here. I want to say that it's a shifted version, although I'm not completely sure. So what happens? What happens if I put a negative 6 here? No, sorry, I put a slider here and that same slider over here. Well, if it's the same, that's gonna be what happens let's just say that this is +5. What happens? Well, that changes it a lot. So let's just say that the A is 0. So let's just put 0 here for A. 0. And let's just say that this is +5. So let me turn on the bottom one. I turn on this one. Let me make sure that they're on the same scale so that I can prove. 15, 15. Here we want 15 and 15. Okay. So I start to see that they're close. I wonder if I can do something about that. So what if I make A increase? And I want A to get to 6. So goes up. We get to 6. Now they should overlap. And if they aren't, then there might be something wrong with this. Scale vector 4, we scale these vectors by 6. Scale this by 6. Now they're completely overlapped. So it really looks like it's a shifted version. Look at what it does. Isn't that even cooler? Might this even be how do we do some animations? I don't know, but this is good. So what if I put this as A? Well, then it's going to change a little bit because they're not the same. I wish they had put the same number here. Well, I guess we can change that. So if this is 6, then look at this. When this is 6, they're the same. Then we shift it and it creates this pattern. Look at that. So it's a shift, but when we do a shift, when we have our little f of x and we shift it up by an amount y, we just get this shift here. This is a little more intricate, and this is because we're dealing with a system. So there's a lot more coupling. I love this. All right. So we've investigated. That's how we investigate. I think this was a success, and I'll see you next time.